Okay, so number 1 on your quadratics check-in asked you to look at a parabola or a quadratic graph and to give some information about it. The first thing that it asked was for the direction. So the direction is asking, does the parabola, which is the shape here, does it open upwards or does it open downwards? So opening up would be like a smiley face, and opening down is like it is here, kind of like a frown. So the direction of this one is down. The second thing it wants is the vertex. So the vertex is a point on the parabola, and it's the very highest or very lowest point. So in this case, it's the very highest point, and it happens right here, right in the center. And that is going to be an actual point with coordinates, so an xy coordinate. So this point here is at the point 2, 1. So the vertex is found at 2, 1. The next thing it asks for is the axis of symmetry. So remember that the axis of symmetry is that line or that axis that creates symmetry in your graph. So think about the fold line. Where would you fold this graph in half so that it was symmetrical? So if we kind of folded it right along this line, that would be the axis of symmetry. So where is that? Well, that's at the line x equals 2. The reason it's written like this is because this is an equation of a line saying that no matter where I am on this line, whether I'm at the point here, which is 2, 3, or the point here, 2, 2, or the point here, 2, 1, or like way down here, 2, negative infinity, all I know is that no matter what, x always equals 2, which is why this is the line x equals 2. The domain is always asking me about some information about my x's. In other words, it's asking me how far to the right or to the left, or how far along this x-axis does my graph go. So because there's arrows on my parabola, it says that it keeps going forever and ever and ever this way, and it keeps going forever and ever and ever this way. In other words, my x values, or the x's that my shape will cover, they are in all real numbers. So that this symbol here just means all real numbers, so it just covers everything going to the left all the way going to the right. So you need to make sure you have that x is in the real numbers. Another way to write this, which some of you have started doing, is saying that that's x being an element of negative infinity, so all the way to the left, going all the way to positive infinity. So two different ways of writing that. Either one of those would accurately show your domain. So the next thing we're going to look at is the range. The range, just like vocal range, like when you think about singing, you go up and down on the vocal range. A range on the graph is very similar. It's asking you about the y's. It's asking how far up and how far down we go. So a good tip with the range is to always use your vertex. So your vertex tells you that the highest point here is 1. So I know that my range is all of the y's that are less than or equal to 1. The reason it's less than is because I'm going down. So my y's start here at 1 and everything else comes below it, not above it. So y is less than or equal to 1. The y-intercept is where our parabola intercepts with the y-axis or the y-line. So here's the y-line, and it intercepts right here. So that means that the y-intercept is where y equals -3. If you want to write that as a point, you can as well. So you could write that that is the point 0, -3, or just writing y equals 3, I'll understand what you mean. And that's how you do the y-intercept. The x-intercepts are similar. If the y-intercept is where it crosses the y-line, then the x-intercepts are where it crosses the x-line. So we cross the x-line here at 1, and we also cross it here at 3. So your x-intercepts are here at where x equals 1, that's one of them, and the other one is when x equals 3. Okay, and again, you could write these as points. You could be that's the point 1, 0, and that's the point 3, 0. Okay, I hope that makes sense for question number 1.